In this video, I'm going to continue with Euclid Book 1, proposition number 45. And I'm going to start with this rectilineal figure. Now, I know I kind of redrew this from the last video, but the reason for this is I had to clearly show you what was going to happen, alright? Now, we have a rectilineal figure, and I think you'll remember the letters A, B, C, and D. Okay, A, B, C, and D. This is a rectilineal figure. I know I redrew it, but you'll understand as I continue with my proof. Okay? Anyway, we also have an angle called E. This is angle E. Okay? Now, if you'll recall from my first video on Euclid Book 1, proposition number 45, Euclid wanted us to draw a line from B to D, thus making two triangles, one bigger than the other. Okay? Now what you're going to do is you're going to reshape this rectilineal figure into a parallelogram. But when you do, that parallelogram that you're going to make is going to have the same amount of area as this rectilineal figure. Okay? So first things first, we actually took the bigger triangle and we made a parallelogram with the same amount of area as the triangle. Now, how did we do this? Okay? We first duplicated the triangle from here to here by using Euclid Book 1, proposition number 22. And then we went over to Euclid Book 1, proposition number 42 and made this rectilineal, well, this parallelogram right here. Okay? Now, we then went over here, hang on, and we duplicated this triangle right here. And when we did, this triangle right here was duplicated right over here. Once again, we used Euclid Book 1, proposition number 22. And then we went right on ahead and used Euclid Book 1, proposition number 42, and we drew this parallelogram. Okay? Now, there's just one problem. The length here, right here, is not the same as the length right here. So if you're going to join parallelogram A right here with parallelogram B, if you're going to put the two together, their lengths have to be exactly the same. Now you say, well, how are we going to achieve that? Well, you're going to go to Euclid Book 1, proposition number 44. Now this is B here. I'm going to turn it back over. Remember, we made a parallelogram, letter B. This is parallelogram B, and we have now duplicated it over here. So this is parallelogram B, okay? And what we did was we made this length from this point here to this point here the same length as the side of A, okay? This side of A, this length right here, is exactly the same as this length right here. Also, this length right here is the same as this length right here. Thus, you now have a parallelogram. Here's parallelogram B, and here's another parallelogram. Okay? And this line right here bisects that parallelogram. But here's another interesting thing you should note right now. If you were to extend this line straight down to here and extend this line straight down to here, they will meet, because this line here is not parallel to this line here. So wherever they meet, you're going to draw yet another line from here to here. Okay? And if you'll remember from Euclid Book 1, proposition number 44, the area of this parallelogram will be exactly the same as the area of this parallelogram. However, the shape of this parallelogram will not be the same as the shape of this parallelogram, because these two lines are a little bigger than these two lines right here. Okay? And it doesn't matter whether these two lines are bigger than these two lines or these two lines are smaller than these two lines. These two lines will not be the same measure as these two lines right here. Now, we've duplicated Book 1 proposition number 44 in order to get these two lines, okay, this area is equal to this area, but these lines are not equal to these lines. What are these lines equal to? They're equal to this. Now we can join this parallelogram, which is A, to this parallelogram, which is B. But how are we going to put them all together? Well, what you're going to do is you're going to form 4 triangles. There's going to be 2 right here and 2 right here. Okay? And when you put these 4 triangles together, and you can do this by using Euclid Book 1 proposition number 22, it's very easy to do. You will finally get this figure right here. Okay? Using Euclid Book 1 proposition number 22, you're going to duplicate parallelogram A, then you're going to duplicate parallelogram B. And when you do, you're going to be able to join these two together. Alright? And the area of this parallelogram will, as we do the proof, will be proven to be the same area as this right here. The area inside of here will be exactly the same as the area inside of here. Now in my next video, I will prove this. But right now you know how to draw this. Okay, that was the first part, was knowing how to draw this. And the next part, I'm going to prove it. So stay tuned.